Hello, Assalamu alaikum. My name is Abdullah Ajmal, and in this video, I will be explaining lab number 5 of microcontroller in embedded system. So, basically, in lab number 5, what we are doing, we are interfacing an LCD screen with our Arduino IDE. So, basically, LCD screen is based on liquid crystal, it stands for liquid crystal display, and it is based on technology of a organic material and trapped between two glass layers, and that is electrified by using some external DC current voltage source, and it displays a particular value that has been engraved onto the polarized glass. So basically, LCD screens are of different type. It depends upon the number of rows and column it displays. The LCD type that we are using is 16 cross 2, which means it has 16 columns and 2 rows. Further, we have 20 cross 2, 20 cross 4, and 16 cross 4 different type of LEDs. And further, the advanced type of LEDs include OLED screen. So basically, for this lab, the equipment that we require is a breadboard, Arduino. LCD displays a variable resistor for the setting the background or backlight contrast of the LCD display, and then we need jumper wires for the connection. So basically we only need to give data to LCD by writing a particular library file, and then further all of the tasks are being done by the between the microcontroller and the LED controller that is already placed on the backside of the LED board, which have its own CG-ROM, CD-RAM, and DD-RAM. So the tasks that we are going to perform in this lab are first making then a particular library file for the LCD, and then the other thing that we are going to do for it is that we are going to make the following the example that are required from us. So first of all, now we will move towards the header files. So this is a particular header file that we have used or we have created for our particular LCD. So it contains all of the command for write enable, read enable, and data transfer. So the mode of communication that we are using is 4-bit communication, or we can also use 8-bit communication, but we are using 4-bit communication. So the commands that we are created include lcd dot integer, lcd data, lcd command, and lcd data string. So basically, lcd dot data we are going to send a simple characters, and lcd dot string underscore string we sending is full to full strings, and lcd dot command we are sending commands to move the cursor to left, right, upper row or lower row, or further commands that are included in it. So, first of all, we will move towards the example number first part, the task that we are required to do perform LED interface to display something that we have written, for example, hello or so some particular name, or display anything. So, this is a task for this is task one. So, added properties, float. This is a task. Let us display. So in this task, the hex file we have written Safirullah Khan 191045. So based on the task, it is displaying the value. So now let us move on towards the task number 2. So we can also see the particular uh, file that we are using, with the particular C main file in which we have written our code. So this is the particular file that we have used. We have sent the data using string command of Safirullah Khan, and then we have sent his roll number out on the LCD display. So now let us move towards the second task. In the second task, we are required to um, perform at Mega. We have do simulation. We are required to implement. I think we are required to implement a particular calculator using this task. So now let us move, and for the final task we are required to form a digital clock using this function. So for the digital clock we have simple created loops for loop for hour, minutes and second, and display the particular values on towards the screen with counting order from 0 to increasing up to 60, and then 59, and then it resets to 0 again, and the value in front of it is changed. So now let us move towards the final simulation of this for task 2. So this is basic calculator for task 2. We will edit properties. Now we will add our files. So we can 1 minus 2 equals to 5. So this calculator is working properly. So we have included two header files. One is the header file of the hex keypad, and other is the header file for LCD. The header file of LCD, as we have seen previous, now we will see the header file of our now we will see the header file of our hex keypad. So basically in the hex keypad we have included the particular commands that first one row will remain high and other row will remain on the top, and then one of the will act as input and one will act as output, and then on the basis of that they will detect that which of the button is pressed and which of the key is pressed for particular 1 2 3 4 5 or particular plus minus addition or equal to operation. And so this is the header file library created for the hex keypad, and these are the functionality for each of the symbol and each of the number written on the hex keypad. So now let us move on towards the final simulation, which is for our digital clock. So this is a simulation for our digital clock properties. Now this is the header file for our hex key, our clock. So basically this clock starts from 1 second and goes up to 99 or 100 hours or whatever the limit we have set, and it will go on forward and forward. We have implemented it based on loops. So now let us stop the simulation, and now we move towards the hardware implementation of this. This is the hardware simulation of our clock. It is working with the increments of out of 57, 58, 59. Now it will update up to 2 seconds. Then we have the second for task 1, in which we have displayed different names. So this is Abdul Ajmal. For the next we have first Safirullah Khan. Then we have for Wajat Kareem Khan for same function for display values. Then we have second function for the calculator. Then we have the same task for calculators. This is multiplication task. Then we have also had the addition task 3 plus 3 equal to. That is again the simulation of the clock which was done. So in this simulation we have also displayed the clock working properly, the counting from 0 to further seconds. So that's all from my side. Thank you for watching.